Hi guys, today's video is going to be about Pythagorean triples, and their formulas actually, that I believe to have found.
I classified Pythagorean triples into two. Type 1, where A is always odd and C is equal to B plus 1. Type 2, A is always a multiple of 4 and C is equal to B plus 2. Now these types, type 1 and type 2, are for Pythagorean triples that are only integers, no decimals. But first, what is a Pythagorean triple? So Pythagorean triples are a set of three integers popularly named a, b, and c. The square of the first plus the square of the second must be equal to the square of the third. Popularly used to find the hidden length of the famous right-angled triangle, the hypotenuse side. If this was 3, this was 4, this would be c. That would mean that 3 squared plus 4 squared would be equal to c squared. 3 squared, 3 times 3, 9 plus 4 times 4, 16 equal to c squared. 25 equals c squared. 25 is equal to 5 times 5, so that's 5 squared is c squared. Find root of 5 squared and root of c squared. Radical cancels into 2, so c is equal to 5. I formulated the formulas on my last term when I was in grade 8, or should I say, a year and some months ago, nearly 2 years. And our teacher gave us a set of Pythagorean triples to memorize because he believed that that was all we needed. And true to his word, that was all that we actually needed. But then I was so curious to find out more on how to make more. Yeah, basically I looked through the list and I tried to find patterns. One thing I found out was most of them started with an odd number. And those that started with an odd number, C was bigger than B by 1. If we look at here, 5 minus 4 is 1, 13 minus 12 is 1. So as 25 minus 24 is 1. And when I reached 8, 15, and 17, I saw that there was a change in both aspects. 8 was a multiple of 2 and 4, an even number. Also, the difference between B and C was 2. It was really strange. So I decided to take that out and work on the ones that started with an odd number. I already had A figured out. There is always an odd number, so it was time to focus on B. I wasn't going to really focus on C because finding B will help me to find C. I just had to add one. I looked through and I realized that they were all multiples of 4. For the differences, I needed to figure out. Therefore, 12 minus 4 is 8. 24 minus 12 is 12. 40 minus 24 is 16. My first instinct was to try to use the equation of a straight line to find a formula of some sort. I have here x, y, so I move 4 to x. The difference between the second b to y is 8. The same with 12, 12 and 24, and 16. Formula for gradient, y2 minus y1 over x2 minus x1. Let's take this one first. 12 minus 8 over 12 minus 4. That gives us 4 over 8. That's 1 over 2. Now let's take the next ones. We have 16 minus 12 over 24 minus 12. That's, as you can see, 4 over 12. And that gives us 1 over 3. I realized at this point that was probably not going to work because different gradients means that it was not going to be a straight line. It's not constant. So I gave up on that. I decided to try to use A in some way to find B. So I decided to use division so that I could find a particular number that I could link to, A that will multiply by A to get B. I basically did a list of B over A's, if I may say so myself. 4 over 3, 12 over 5, 24 over 7, 40 over 9. Here I got one whole number, 1 over 3. Here 2 whole number, 2 over 5. Here 3 whole number, 3 over 7. As you surely guessed, 4 whole number, 4 over 9. So here I'm getting somewhere. I realized that these match. So I was going to equate them to x. That would mean that I write this in the form of x whole number x over a. This multiplied by a should give me b. That's 4 over 3 times 3 gives us 4, which is b. X whole number x over a times a equal to b. I decided to make this into an improper fraction, so that's ax plus x over A times A equal to B. A cancels A, then we get AX plus X is equal to B. Finally, we have a formula, but then how to determine X is the problem. I decided to look back here. And list them down. X and A, my list ended up being 3, 1, 5, 2, 7, 3, 9, 4. I could use the equation of a straight line to find this, but easily you can see that when you divide 3 by 2, you get 1 and a half. You subtract the half, you get 1. Same applies to 5, 7, 9. 5 over 2 is equal to 2.5. You subtract the half, you get 2. So I wrote it as A over 2 minus 1 over 2. It could be simplified as A minus 1 over 2. I prefer to keep it this way. Now we get a formula. AX plus X is equal to B, and X is equal to A over 2 minus 1 over 2. C, as stated earlier, is going to be B plus 1. It is also X plus 1. Now let's test this out. Type 1. AX plus X is equal to B. X is equal to A over 2 minus 1 over 2, and C is equal to B plus 1. I might as well write it down. I'm going to test it. Okay, one number. 2025, I choose that. If A is 2025, then what if I find X? X is equal to 2025 minus 1 over 2. That's 2024 over 2. That's 1012, I hope. 1012. We have to find B. That's 2025 times 1012 plus 1012. For this, just for proving stuff, I'm going to use my trusty Casio calculator for this one. We got 2025 times 1012 plus 1012. Okay, we got a pretty big number. 2,050,312. That's B, and C is B plus 1. So I might just take the triple out right now. 2025, 2,050,312, and 2,050,313. Once again, we're going to use our calculator to cross-check if this is right. 2025 squared plus 2,050,312 squared, simultaneously with 2,050,313 squared. It's a pretty big number. Times 10 raised to the power 12. We see that it's correct, valid, type 1. With type 2, that time I only had 8, 15, and 17. My chances of finding the rest were pretty slim because, it's just 1. Since the equation of a straight line thing didn't work for the first one, well, this one wouldn't work because there's no comparison. I decided to use the division, 15 over 8. I got one whole number, 7 over 8. And because I was pretty desperate at the time, I decided to try some stuff. So if 1 once again equated to X, we have our A over here. 7 at the top would be A minus 1. Yeah. Once again, we do this X whole number, A minus 1 over A times A is equal to B. Move into improper fraction. We've got AX plus A minus 1 over A times A equal to B. A cancels A, so we've got AX plus A minus 1 is equal to B. That was quick. Nice. And C, as usual, is equal to B plus 2. Let's test this out. If A is 2025, X would be, oh yeah, what's X? Okay, so what did I do when I was pretty annoyed at the time? Came so close yet so far. I wondered what X was. Over here, 1 was X. If I took X as constant for 1, that would be stupid. I decided to do something desperate. If you divide 8, knowing that 8 was a multiple of 2 and 4, divided 8 by 2, I got 4. 4 minus 3, give me 1. 3 I didn't like. It looked big. I thought I should divide it to the least number. So I decided to divide 8 by 4. That gave me 2 minus 1. That gave me 1. A over 4 minus 1. Okay, I wanted to test this, but I realized something stupid. 2025 is not a multiple of 4. Damn it. Okay, wait, what did I just say? 2025 is not a multiple of 4? Yeah, so instead of that, I will use 2024. 2024 over 4. Too lazy. I'm going to use my calculator. 506 minus 1. It's 505. Okay, so now time for B. B equal to 2,024 times 505 plus 2,024 minus 1. Go back to the calculator again, okay? Another million, 1,024,143. And C is supposed to be B plus 2. That's 1,024,145. We assemble them. Triples assemble. Trusty calculator. Oh shit, okay. Once again, times 10 to the power of 12. Really big number, but the answer is still the same, which means that this is valid. Type 2, valid. Okay, a brief summary. Pythagorean triples, a set of integers where the first square plus the second square is equal to the third square. Classify them into two where A in type 1, A is always odd, C is equal to B plus 1. Type 2 is always A is multiple of 4, C is equal to B plus 2. Tried to find some patterns using B in the equation of a straight line. Didn't work. So I tried division. Worked. We found a formula, but then we didn't have a very important variable x. But then we figured it out. Type 1, we tried the dummy number on it, and yeah, it worked. Type 2, we didn't have any triples to compare it with, so we forgot about the gradient and the equation of a straight line. We moved on, did some guessing, worked, got frustrated, and then eventually we won. So yeah, found this nearly 2 years ago, but I'm still not sure if this exists before. I know it probably exists because, there are multiple geniuses, but I'd like to know if this really exists. If this really exists, I'd like to know who found it, and I'd like to know more about it and how it was discovered. Drop it in the comments. Like, share, comment, and subscribe. Thanks.